Good morning and Jai Swaminarayan to all. Hope you all are safe and healthy in this pandemic situation. Now, today we are starting a new subject, that is digital signal processing. So, now you are in semester 7. So, up to till semester 6, you learn so many subjects regarding electronics and communication. Now, in all that system, nowadays our system may change to a digital era. So, for that, we must need to get a knowledge about the digital electronics. So how a digital system will work. So for that, to understand the digital system, we must aware with the digital signal processing. So digital signal processing contains a three words, that is digital, signal and processing. I know for that you have some of the prerequisites knowledge is required. So prior to start the digital signal processing, you are aware about a basic electronics, higher engineering mathematics, different transforms like Fourier series, Laplace transforms and Z transforms, and signal and system. All that subject I think you learned in your previous semester. In basic, why we need to understand the basic electronics? So to get a detailed knowledge about any signal, we must know about how a signal can be generated and how it can be processed. And the two domains are there that we know. One is a digital and one in analog. So to get a clear idea about a difference between digital and analog systems, we have a prior knowledge about basic electronics. Higher engineering mathematics. So why we need a higher engineering mathematics? So digital signal process can be carried out by mathematical manipulation, and we need to change the domain of functions. We all know the signal and system can be defined in a mathematical expression. So how that mathematical expression can deals with a signal expression? For that we have a knowledge about higher engineering mathematics. So within a mathematics, a different transforms that are Fourier transform, Laplace transform and Z transforms. So Fourier transform is used to find out the coefficients of our filter, which is being used for the filtering applications. Laplace transform and Z transform, another two transforms are there that are also used to realization of any digital circuit for the signal processing. And signal and system, you are very much aware about the signal and system. Now, according to syllabus, there are few contents are there. So among of them, we are now starting the first topic, that is introduction to DSP. So introduction to DSP, in that topic the overview of signal, system and processing. So we get the knowledge about signal, system and processing. Then classification of signals, different types of signals are there, how they are classified with their properties, with their parameters. So we will see that classification of signals later on. The elements of digital signal processing system. So how a digital system can be characterized and how it works and how that system will deals with the signal. So that we understand in the elements of digital signal processing system. Then we go for the concept of frequency in continuous and discrete time signals. You already know the continuous and discrete time signals. They are the synonyms of analog signal and digital signal. So how a continuous signal and discrete signal can be represented in a frequency domain. So that we understand, and why we need to understand the frequency domain concept of that continuous and discrete time signal, by getting a behavior of our samples in a frequency domain. we get a detailed information about the different spectra, frequency component within it. So we need to understand that concept of frequency in continuous and discrete time signals. Then periodic sampling, frequency domain representation of sampling. Now overview of signal. So you already know the signal. What is signal? How it can be dealt with the various systems. So as we know, signal is a flow of information. Simply. So how information can be transferred from one end to another end. So that information is being transferred from one system to another system, that is called a signal. Sometimes signal can be defined. A signal is a function of one or more variable that conveys the information about some phenomena, usually physical phenomena. Why physical? Because we know temperature, light, sound, all this information, basic information are in an analog domain. So we have to deal with that physical parameter of that particular signal generation system, and that is converted into a electrical signal, and that is being transferred. So signal plays a major role in our life. In general, a signal can be function of time, distance, position, temperature, pressure, etc. And it is represent some variable of interest associated with the system. Now, for the example, let me take the measure quantity that varies with time or position. Now, let me take an example. For example, in electrical system, the associated signal are electrical current and voltage. So how a different electrical signal we received from a transducer? So we know the various transducers are there, that are microphone, thermometer, accelerometer, antenna, etc. We know how a microphone will work. Microphone can act as a transducer, and it converts a physical parameter into an electrical signal. What is the physical parameter? How a microphone can convert a physical parameter? A voice signal. What is the voice signal? Voice signal is a compression and rarefaction of a sound wave. That is a physical signal. So that compression and rarefaction can be converted into an electrical signal. So that signal is being received from that transducer, and that is fed to our system, that is amplifier, and our voice can be amplified. Thermometer, again various types of transducers are there. PTC is there, NTC is there, that are called the temperature sensing device. So how the temperature sensing device? Okay, they are its conductivity is changed according to the temperature. So accordingly, whenever the temperature is changed for that particular transducer, NTC or a thermistor, so thermistor's characteristics, whenever the temperature is changed, its resistance is changed, and accordingly its current passed through it is changed, and that is being changed in our signal, and that change is a signal. So that change is considered as a signal, and that signal is fed to our next stage of our system. Accelerometer in our any vehicles, antenna. We all are its antenna is a very common word. What is the job of function of antenna? The function of antenna is to receive a signal, right, from a electromagnetic wave to electrical signal. So the air wave can be converted into an electrical signal. That is the job of our antenna. So we can get a detail of how a signal can be worked. A signal can be represented in the number of ways. Most of the signals that we come across, that is generated naturally. Whatever that we discuss right now about signal, they are generated naturally. However, there are some signals that are generated synthetically. In general, the signal carries the information, and objective of the signal processing is to extract the information from it. So we get a few of introduction level of the signal. Here is an example. We already discussed the example of signal, that is for the electrical system, voltage and current is there. For the mechanical system, force, speed, torque, etc. are considered as a example of signal. Once again, I already stated that information. In general, the signal carries the information, and the objective of the signal processing is to extract the information from it. Okay, so now we get the information about signal. What is signal, how it can be generated, how it needs to be processed, and what is the signal parameters, how it can be defined. It can be defined with the mathematically as well as physically. Now the next is overview of signal processing. So signal processing is a method of extracting information from the signal. In turn, depends on the type of signal and the nature of information it carries. Thus, signal processing is concerned with the representing signals in mathematical terms and extending the information by carrying out the algorithmic operation on a signal. The signal processing concerned with the presenting signal in mathematical terms and extracting the information by carrying out the algorithmic operation on the signal. Mathematically, a signal can be presented in terms of basic function in the domain of original independent variable, or it can be presented in terms of basic function in the transformed domain. That means we can extract the information from its original domain. What does it mean? So mathematically we can express any signal in a mathematical way. Let me take an example. A sinusoidal wave is there. What is the expression for sinusoidal wave? That is f of x is equal to Vm sine of omega t, right? So A represents the peak amplitude and the omega is our angular frequency and t is the parameter. So f of t is equal to A sine of omega t. So in that expression we can get the information about the amplitude of our signal at any time. Whenever we, at what time, what will be the value of amplitude we can calculate. So it is its time domain representation, and we can get the peak or amplitude information from its time. So now, so that's why the statement is written such like that the original independent variable. What will be the original independent variable? That is the peak voltage is the independent variable, and that is related with time. So whenever the time is changed, we may get the variation in voltage. So now we can get the information of voltage with respect to time. Now this line stated that it can be presented in terms of basic function in a transform domain. So we all are aware, right? We all are aware with the spectrum. You all know what is spectrum. whenever we take a Fourier transform of any function and we can represent it in terms of infinite series. What is this infinite series? That all the terms in that Fourier series are called a spectra, and the graphically representation of Fourier transform of any function is called a spectrum. So now we change the time domain to frequency domain of any function. We have to take its Fourier transform. So once a transform is changed, we may get the detail about frequency values. What are the frequency component are present in spectrum that can be carried out by Fourier transform. So we may get a detailed information about spectrum. Spectrum means a variable frequency. So which are the frequency component are present in our signal, that is called a transform domain. So we may get a detailed information from its transform domain also. The information contained in the signal can also be extracted either in the original domain or in the transform domain. We can extract the information from its original or in the transform domain, both. Now we take overview of our system. Till now we know about the overview of signal, overview of processing, and now overview of system. A system may be defined as an integer unit composed of a diverse interacting structure to perform a desired task. Desired task, what does it mean? The task may vary, such as filtering of a noise in a communication receiver. We all are aware that channel is a noise additive. So in a communication, channel plays a vital role between source and destination. Our information is being conveyed to destination from the source via channel, and channel is always at a noise. So we must need to remove the noise to extract the information from our received signal, which is being transmitted without noise. So our receiver receives two signals, one is an information and another is noise. So we need to remove that noise. So how it can be carried out? So that is called a processing, and that process is called a filtering process. So once again, this is called a filter system. Now detection range of a target in a radar system. That is also one task. That system has to identify the object. If any unknown object comes in our range of radar, that is being transmitted, that is being received information about object, and some of the command that is being transferred to our target. So that is also one type of process, and the entire system that is called a radar system. Monitoring system of pressure in a boiler, temperature of a boiler, etc. So to monitor an entire mechanical system, we have to develop a system that works with the electrical signal that is received from a various sensors, and again what action we have to take against that signal, that information is also being transmitted to our actuators or our system, and it function accordingly. The function of system is to process a given input sequence to generate an output sequence. We see in our above examples, filtering process, what is its input? Its input is noise plus signal. Noisy signal is its input. What is its output? Original signal is our output. So we want to eliminate the noise. So that, what is the system? If we say that it's a filter, so how it works? What is the functionality of that system? Okay, for input of that system is noisy signal, and what is the output? Our output is a pure signal. So noise can be eliminated. Similar way, monitoring system of any mechanical industry, that is also a system. Its input is what? Various physical parameters are there, that is input to our system, and what is our output? We have to take the decision, and whether we want to increase the temperature, decrease the temperature, increase the pressure, temperature, etc. That action can be taken by our system. So that is called a mechanical monitoring system. Now What is digital signal processing? Sorry, why digital signal processing? We get the knowledge of some overview about signal, overview about signal processing, overview about system. Now, why digital signal processing? We already stated that now entire world switch over in a digital domain. So we must need to understand the how a digital system can work. So once we know, we already defined the system. What is system? System means it has some inputs, process on the input, and it generates some output. Now in our case, signal is our input, output is also signal, so it is called a signal processing. Now which type of signal we deals with the system? Our system is deals with the digital signal, then it calls a digital system. So our system having a digital input, processed digitally, and generates a digital signal, so that is called a digital signal processing. So why digital signal processing? There are some of the advantages we discussed right now. Why digital signal processing? So digital circuits do not depend on the precise value of digital signal for their operations. We already know that precise values of digital signal. We know how a digital signal is in a binary form. So there is only 1 and 0 states are there. It's a logic level signal. So if a 0 state is there and logic level 1 state is there, if we define a 0 to 1 volt as a logic level 0, so whenever our input signal having a values within a range of 0 to 1, so it is always considered as a logic level 0. And if we define as a voltage for 4.5 to 5 volt as a logic level 1, so it always considered as a logic level 1 when our input voltage or a pin voltage is 4.5 to 5. So irrespective of value, whether it is 4.6, 4.7, 4.8 or 5, it always considered as a logic level 1. And whenever the input voltage is 0, 0.1, 0.2, 0.3 up to 0.9, it always considered as a logic level 0. So we do not require a precise value of our signal for their operation. Digital circuits are less sensitive to change in components value. We all know how a digital circuits can be made. So digital circuit contains some of the programmable components and memories. So whenever we change any component, they are identical. That deals with the digital signal. So there is no need to find out the exact value of that component. So irrespective of change, whenever we change the processor, we do not require to reconfigure it and reset the values of all. Whatever the program is being loaded in the processor, it will work accordingly. So digital circuits are less sensitive to change in component values. They also less sensitive to temperature, aging and other external parameters. We know for our analog system, whenever the supply voltage is changed, so our entire output is changed. But in digital, whenever the voltage is changed, we may not get any kind of change variation in our output as they have a fixed values. Digital processing of a signal facilitates the sharing of signal processor among a number of signals by time sharing. This reduces the processing cost per signal. It means TDMA, time division multiplexing, is possible in digital only. Whenever a one signal is processed, and then we will have to wait for the next sample till that our processor is idle. So it can receive another signal from another system. It is being processed and generate an output and given back to the other system. So this is a time division multiple access. Our single processor can deals with a multiple signal for processing. Digital implementation of a system allows easy adjustment of the processor characteristics during processing. With digital filters, linear phase characteristics can be achieved, which is not possible with the analog techniques. We know no one analog filter can provide us a linear phase characteristics, and digital filters provides us a linear phase characteristics. This is the biggest advantage of our digital signal processing. Multi-rate processing is possible only in digital domain. Digital circuit can be connected in cascade without any loading problem, where this cannot be easily done with the analog circuit. We know whenever we need to cascade two circuitry, we must need to match their impedance. Impedance matching must be there to get maximum power transfer. Now in analog circuit, all the preceding state or stage is suffer from a loading effect of its next stage. So that type of problem cannot arise in our digital system. Digital system deals with the digital signal only. Why we need to impedance matching? To get maximum power. By impedance matching, we may try to reduce our loss of information. In analog signal, storage of digital data is very easy. We know signal can be stored in a various storage media such as magnetic tape, disk and optical disk without any loss. On the other hand, the storage of analog signal deteriorates rapidly as a time progresses and cannot be recovered in their original form. For the processing very low frequency signals like seismic signals, analog circuit required an inductor and capacitor of a very large size, whereas digital signal processing is more suited for such applications because there is no need of any kind of inductor or capacitor. It is a algorithm which deals with the sample only. Though there are many advantages, right? These are the advantages of our digital signal processing. That's why now entire world is switched over to digital signal processing. Now some of the facts about digital signal processing. Facts means a drawback. Though there are so many advantages, some of the drawbacks are there. Each and every system have a drawbacks. Now, and digital system also have it. Though many advantage, there are some drawbacks associated with the processing a signal in digital domain. Digital processing needs a pre and post processing like digital to analog and analog to digital converter and associated reconstruction filters. Also, digital techniques suffers from a frequency limitation. For the reconstruction of a signal from its simple, sampling frequency must be at least twice the highest frequency component present in that signal. That is a statement of our sampling frequency or Nyquist frequency. The available frequency range of operation of digital signal processor is primarily determined by the sample and hold circuit. We all know what is the function of sample and hold. So sample and hold is a part of analog to digital converter and the result is limited by the technology. Means the hold time. We need to hold a value of sample for a certain time. So that time is our main restriction, and time 1 hour t, that is f. So our digital system is restricted by f, that is frequency. So thank you very much for listening this. Now in our next session we will talk on classification of signals. Thank you very much.